Example 1.10. Two charges plus or minus 10 microcoulomb are placed 5 millimeter apart. Determine the electric field at A point B on the axis of the dipole 15 centimeter away from its center O on the side of the positive charge as shown in the figure. 1.21A and B, a point Q 15 centimeter away from O on the line passing through O, normal to the axis of the dipole, also shown in the figure. Okay, what we have to find out, first we'll go through the question again. There minus 10 and plus 10, two charges are separated. Once again, it is a dipole, but the separation between the dipole, that is dipole length, is 5 millimeter. We have to find the electric field at a point P, which is at the distance of 15 centimeter away from the center. Matlab center is O, O to P distance is 15 centimeter. So, after reading, you have to compare the values. Dipole length is 5 millimeter. At the separation of 150 millimeter, we have to find out. So, you can conclude that given dipole is a short dipole. Even though it is not mentioned in the question, by comparing the values, you should come to the conclusion that it is a short dipole. Okay. Now, we will start with the first part now. Charge Q is given, dipole length separation is given, distance R, that is 0.15 meter. Dipole moment first we'll calculate. Dipole moment formula Q into 2D separation. Therefore, you are getting 5 into 10 to the power minus 8 coulomb meter. Okay. Then, along the axial line, that point P comes along the axis, right? O to P separation is given. Along the axial line, in the case of short dipole, electric field is 1 by 4 pi epsilon naught 2p by r cube. 1 by 4 pi epsilon naught value 9 into 10 to the power 9. 2 into dipole moment we have found here 5 into 10 to the power minus 8 divided by r cube. R means OP value. OP value given as 15 centimeter convert to meter. So 0.15 whole cube. So if you are simplifying, you are getting nearly 2.67 into 10 to the power 5 Newton per coulomb. Now, so electric field along the axis is 2.7 10 to the power 5 Newton per coulomb. In which direction? Which direction? Along the axial line, net electric field is in the direction of dipole moment. Dipole moment is from A to B, negative to positive. So it is acting along right. Okay. Now we'll come to equatorial line. In the case of short dipole, electric field intensity along the equatorial line is P by 4 pi epsilon naught R cube. So 1 by 4 pi epsilon naught 9 into 10 to the power 9. P value 5 into 10 to the power minus 8 divided by R cube. This separation is 0.15 whole cube. And if you simplify, you are getting 1.33 10 to the power 5 Newton per coulomb. We got the magnitude. Now we have to attach the direction. What will be the direction? Direction of the net electric field along the equatorial line is always opposite to the dipole moment. Dipole moment is negative to positive. So this direction is positive to negative or towards left. Opposite to the dipole moment, that is towards left.